Hello all, welcome to my YouTube lecture. I'm Shrikanth Shirakol. We are studying about behavioral modeling. In this session, we'll look into writing a Verilog code for a shift register. Shift register is nothing but a series of flip-flops that is how we have studied in digital circuits. Herein, we are just designing a 4-bit shift register which has a power to shift the stored number either to the left of it or to the right of it, based on the instructions that we specify. So here is a code, small piece of code that I can explain it. Just go through the lines. Uh, Shift register is a module name, an identifier, clock and reset, and A. Three inputs are there. Q is the output of 4 bits. I have defined the same here. And as we are using Q inside the always block, we are defining it as also as register of 4-bit, and we are initializing it to 1010. This is a number which I want to either shift it to left or shift it to right. So always at posage of clock, if reset, Q should be 0. Then after that, if reset is not um, if reset is 1, Q should be 0. If reset is 0, then this particular statement will be executed. So here so here in the shift register, let me repeat, in the left shift, whenever we feed a value 1010, so after the first time left shift, this 1 will be shifted and will go out. 0 comes to the MSB, 1 comes to the next to MSB. The same thing is shown here, and the left out bit or the vacant bit will be filled with 0. And this decision we can just make ourselves, because here I have decided it to fill with 0. You can fill it with 1 or anything else. And one more time left shift, this one will take the most significant bit, and one more time, so it will be occupied with all zeros. If in case we take the initial value and right shift it, the values are like this. First time right shift, this one occupies the least significant bit, and this one occupies the next here, this bit Q2 bit, and this Q3 will be vacant bit and will be filled with 0. And again, this also you can decide. So here A, I have taken a signal wherein it decides whether to go for left shift or right shift. A is equal to 1 makes the left shift, A equal to 0 makes the right shift. So this code will just analyze using xilinx. So in xilinx environment, I have taken the code. So I just simulated it. I just synthesized it. Let me simulate it and check whether the output behaves in the same manner how we discussed. So its simulation is on. My initial value is 1010. So you don't restart it because initial value have forced it 1010. If you just restart it, then this will get vanished. I force the clock 0, 1, 100 nanoseconds. Okay. Reset constant. I keep the reset 0, and then I keep A is equal to 1, means left shift. A is equal to 1, left shift. So I run it, zoom to fit. You can check here 1010 left shift. So this one is it's taken out. 0 occupies the most significant bit. This 1 comes to the next to most significant bit. The vacant bit will be filled with 0. One more time left shift, one more time left shift. So this is how the left shift and right shift operations takes place. By a small modification, you can make a ring counter with this, and that I leave it as an assignment for you. Just a hint is, see here, if I just replace 0 with Q3 bit, what happens? So Q3 bit is assigned to Q2, Q2 bit is assigned to Q1, Q1 to Q0, and Q0 will be Q3. It's a rotation operation. Try it with this, but one problem is what that you face is Q3 bit will be assigned with Q2, and then you try to assign the new Q3 bit to Q0. This is somewhere you're committing a mistake. So that's why before this Q3 bit gets vanished, make sure that you define one temporary register and assign your Q3 value to it, so that its value is retained, and in temporary variable your Q3 bit will be there, Q3 value will be there. So that value I'll fill it here. So this makes the rotation operation successful. Try to check it, try to implement it, take it as an assignment for you. If any doubts, please comment in the comment box. I'll try to answer your queries. Thank you. To keep updated, kindly subscribe the YouTube channel.